Alrighty, so this is our FRQ practice for week 4. Let's begin here. So the function j of x is equal to 2 to the power of g of x is given. We want to find j prime of negative 2. So that means I would need to find the derivative of this function first, and then I would plug in negative 2. My guess is that this would be a 2-point question on an FRQ. 1 point would be given for the derivative. The other point would be given for the final answer after you plug in the negative 2. So let's go ahead and begin here. So first of all, let's take note of the fact that I've got j of x is a composite function. I've got the outside function, which is 2 to a power. And then I've got my inside function, which is g of x. So if I wanted to find the derivative of j, then we're going to be applying the chain rule. Being messy here. Let me rewrite this somewhere else so I don't make a mess. All right, so how do you find the derivative of an exponential function? Well, the derivative of an exponential function is always going to be the same thing as it was anyway. So it's just 2 to the power of g of x. But if it's something other than base e, which it is in this case, then you have to also multiply it by ln of that base. So we have ln of 2 times 2 to the g of x power. That's the derivative of the outside. Now I want to do the derivative of the inside, which is g there. So that would just be g prime of x. So that there would be worth 1 point on your FRQ. The other point can be earned by plugging in the negative 2 and simplifying it. So we have j prime of negative 2 now. So that's going to be ln of 2 times 2 raised to the power of g of 2 times g prime of 2. So all I've done is I've replaced the x's with negative, should be negative 2 actually. All I've done is I've replaced the x's with negative 2. So this is going to stay as ln of 2. You can't really do anything with that. But this guy here can be simplified. G of negative 2 is negative 1. And then g prime of negative 2 is 2. Now, 2 to the negative 1 power, that basically means 1 over 2. So let me start up here now. Right in this space, I've got ln of 2 times, this is going to be written as 1/2, and then we have times 2. Now these cancel each other out, and therefore j prime of negative 2 is equal to ln of 2, and we're done. That's as far as we're going to take it. Okay? So that would be worth the other point there. So we have 2 points. 1 point is for the derivative, 1 point is for the answer. Let's go ahead and take a look at our next one. All right. Some writing space for myself here. All right. Let h of x be this function, and a is just a positive constant. So a is like a number in other words. So part A is asking me to find f prime of x. So if this is my function, if h of x is equal to cosine of 3x squared plus ax, I meant to put here, I just realized I have an error, that was supposed to be an h on both of those. We want to find for part A, h prime. So right now, that's just going to be a chain rule. We have the outside, and then we have the inside. Okay, so if I wanted to find h prime, we're going to do the derivative of the outside times the derivative of the inside. Now, the derivative of the outside, the derivative of cosine is negative sine. The inside will stay the same for now. And then the derivative of the inside, the derivative of 3x squared is 6x. and the derivative of ax is just going to be a. So a is kind of like a number. Like if that was 3x, the derivative would be 3. But in this case, since it's ax, the derivative is just a. So there's my first derivative, and that's part A, and that would be worth 1 point. Okay. Now part B, they're going to ask me to do the second derivative. And I gave you a hint there. I said use the product rule. Because we have two pieces. We have this piece, which we'll call A, and then we have this piece, which I'll call B. Okay? So it's A times B, A times B, where you have derivatives on the A and the B on these different sets. So, let's begin. So if I want to take the derivative of A, that's the green part there, the first thing I want to keep in mind is that's another chain rule. So I have negative sign as my outside function, and then 3x squared plus ax is my inside function. So if I want to find a prime, it's going to have two parts to it, the derivative of the outside times the derivative of the inside. So let's do the derivative of the outside. The derivative of negative sign. Well, sine is just cosine, but there is that negative in the front, so it's going to be negative cosine. And then the inside will stay the same, 3x squared plus ax, getting kind of tight there. And then we have the derivative of the orange spot, which is 6x plus a again. So that's the derivative of a. Now we're going to put b in there. Then we're going to put a. Maybe I'll keep that in green just to be consistent with my colors. And then finally b prime. So the derivative of this, the derivative of 6x will be 6, and the derivative of a is just 0 since it's like a constant. And there you have it. And that's good enough for an FRQ. I would leave it like that. I wouldn't do anything else. Okay? So there's your second derivative. So that's parts A and B, and they would both be worth 1 point, so 2-point question once again. Let's go ahead and take a look at our last one here, number 3. All right, the function f is defined by this. Find f prime of x. So here we go. Another chain rule. So my outside function is the ln that's there. My inside function is the x squared minus 4. Now, to take the derivative, we're going to do the derivative of the outside multiplied by the derivative of the inside. Now the outside is ln, so anytime you take the derivative of an ln, it's just 1 over whatever the inside is. Then the derivative of the inside piece is just 2x. And then we can put those together where we put the 2x in the numerator there. And this cannot be reduced, so that's our answer for 3a. Now, that's going to be helpful for the next part, so I'm going to leave that up there. But that's the answer to a, and that would be worth 1 point probably just for finding the derivative. Okay? Now, part B wants us to find the equation of the line that's tangent to the graph of f at x equals 3. So anytime we want to find a tangent line, we need a couple of things. We need an x, we need a y, and we need a slope. The x is given, so that's 3. To find the y, you plug it into the original function. So that's 9 minus 4, which is 5. Now that's a weird y value, but there it is. My y is ln of 5. Next, we need to find our slope. To find your slope, you're going to plug your x value into your derivative, which we've already found. And that's going to be 6 over 5. So I've got my x, I've got my y, I've got my slope. Therefore, my final answer is going to be y equals m times x minus the x value they gave plus the y value that we found. All right. Since we already found the derivative, I'm pretty sure that this part would only be worth one point. They're not going to give you a point for finding y. They won't give you the point if you don't do it, but they're considering this to be like a pre-calculus thing, so they're not going to probably give points for that. They're not going to give points for just plugging it into the derivative either. So long as you can find those two things, don't put it in an actual equation, they probably give you a point there. Now, in some questions, they might just put these together as one question, in which case then it would be worth 2 points. But in this case, my guess is that they would give 1 point for this and 1 point for that. And they're only going to give 1 point for the last one because half the work was already done in part A. All right, so there you guys go. Hopefully that was helpful, and we'll see you guys later.